In this video, we'll be differentiating another logarithmic function. Our problem is that we want to differentiate y equals the natural log of the cube root of x minus 1 over x plus 1. Now let's rewrite this. We know that when we have a radical, we can write it using exponents. So this function becomes y equals ln of x minus 1 over x plus 1 raised to the 1/3 power. Now we're going to use property 4, which says that the log of a to the n power is equal to n times the log of a. So this is y equals 1/3 ln x minus 1 over x plus 1. Now we could at this point let u be the argument and use the quotient rule, but we also have another property of logarithms that says if we have the log of a quotient that's equal to the difference of the individual logarithms. So we can write this log of this quotient as ln of x minus 1 subtract ln of x plus 1. Alright, now we can differentiate dy dx equals, and the reason that I'm not using u on the x minus 1 is because if we have u equal x minus 1 and we do a derivative on that, du dx, it's just going to be 1. So we don't need to put that in there. And again, you can if you want to. Alright, so the derivative here is going to be 1/3. The derivative of ln x minus 1 is 1 over x minus 1. Subtract, and then the derivative of ln x plus 1 is 1 over x plus 1. We can get a common denominator here to simplify this. Multiply up here, top and bottom, by x plus 1, and top and bottom here by x minus 1. And I'll have x plus 1 times x minus 1. Need to distribute this negative through the binomial. So I have dy dx equals 1/3, and then when I distribute this minus, this x is a negative x, and that'll cancel with this positive x. So those are going to go away. And then this will become a positive 1 right here. And then I have this positive 1. So I have 2 over. And then when I multiply these two binomials together, I get x squared minus 1. And then we could rewrite this as 2 over 3 times x squared minus 1. Let's do another one. We're asked to differentiate f of x equals ln of cube root 1 minus x. So again, let's rewrite this with an exponent. This becomes y equals ln 1 minus x to the 1/3 power. And then we can bring this 1/3 out in front of the logarithm. So we have y equals 1/3 ln of 1 minus x. Now on this one we need to use our u substitution. U is equal to 1 minus x. And then when we do a derivative, du dx, we have 0 minus 1. So that's equal to a negative 1. Now dy dx is equal to 1/3 times 1 over 1 minus x times this derivative, which is negative 1. And this negative 1 we can take in here. So we have 1 over 3 times. When we distribute this negative 1, this becomes a negative 1 and the x becomes positive. So we can turn this around, be x minus 1. Now we do need to state, remember that the argument must be positive. So 1 minus x needs to be greater than 0. Subtract 1 from both sides, and we have negative x has to be greater than negative 1. And then when we divide by a negative 1, x is less than 1. So we need to also state here that x is less than 1.